The second part focus on introduction, yeah, about the characterization of composite, a little bit introduction about manufacturing of composite and so on. Hopefully during this week, yeah, we'll have you know, the idea to share with you, yeah, about how is it possible to manufacturing and which are the main steps in order to make the characterization of composite. I mean a composite of metallic matrix, I mean the composite of the ceramic matrix and polymer matrix, yeah? It's quite important. During my presentation, or you will see after 2 or 3 days, yeah, a little bit characterization of biodegradable material, yeah, obtained by, let's say, injection molding and 3D printings, because as you already know, it's important the biodegradable material for the environment and last but not least for our life, yeah. I mean, in order to replace as much as possible the plastic material with biodegradable material. So I'm working on Gheorghe Technical University. It's the oldest, let's say, environment education in Romania, yeah, more than 200 years ago. Iași is one of the most beautiful city of Romania, I mean the culture city of Romania. You'll see a little bit, I think, yeah. You can see the excellency and tradition of in education in our university. The Technical University of Iași, I think it's not working because, yes, because of the screen. Yeah, I cannot show because of the screen. Our university is member of the Ingenium Alliance of European Universities, yeah. And let's see over there a brief history about our university. I would like to start with the Latin School, which was the first attempt to set up a form of the higher education in the region of Moldova. Don't make, you know, a mistake about Moldova and the Republic of Moldova, okay? The Republic of Moldova, it's, let's say, former part of the Soviet Union. We have border now with the Republic of Moldova, but Moldova, it's the part, let's say, the area of Romania, the region, yeah, of Romania. Another important step you can see in 1813, the Gheorghe is promoting the foundation, okay, taught in Romania. The class is founded on 15 November 1813. The next step, 1835, Gheorghe Asaki is actively involved in establishing the Mihaileana Academy, yeah, which, let's say, comprise technical courses and the painting school. Another step, 1860, the first modern university, I mean University of Iași, yeah, was established at Iași. Later it will be named Alexandru Ioan Cuza University, I mean the oldest university in Romania. Of course, there is university today, Alexandru Ioan Cuza University. The next step, industrial electricity and technological chemistry. Altogether, the intention over there to recreating the technical education at Iași University and to specialization begins the activity. I mean the industrial electricity and the technological chemistry. The next step, I mean, as my opinion, as our opinion, the important one, in 1937, the Polytechnic School Gheorghe is founded, and Professor Cristea Otin was the first rector of our university. The conference room in our university has the name Constantin Cristea Otin. The next step, in 1988, the Polytechnic School Gheorghe becomes Gheorghe Polytechnical Institute of Iași, and started in 1993 after Romanian Revolution, okay? The Technical Institute became Gheorghe Technical University of Iași. Of course, after the revolution, the mechanical engineering faculty was split in 3 main faculties. I mean the materials engineering, mechanical engineering, and the faculty where I'm working, the machine manufacturing and industrial management. Of course, a little bit maybe strange, yeah, because you know, when we are talking about the technology, mechanical and so on, yeah, are together, let's say, on the side of mechanical engineering, but it's a structure after Romanian Revolution. So inside of our faculties, there are 11 faculties. Yeah, you can see over there. Let's start with automatic control and computer engineering, faculty of architecture, faculty of chemical engineering and environment protection, faculty of industrial design and business management, faculty of material science and engineering, mechanical engineering, electrical engineering, faculty of hydrotechnical engineering, geodesy and environment engineering, faculty of electronics, telecommunication and information technology, faculty of machine manufacturing and industrial management, the faculty where I'm working, and the faculty of civil engineering and building services. So, which is our, let's say, our position in Europe? So, as I said, you can see, I'm sorry because I cannot show. Do you know why? Because of the screen. Yeah. Yeah. It's important to show, but I don't know what I have to do. Maybe the other. Maybe the other. Maybe the other is better. My city is on northeast of Romania, and as I mentioned, we have border with Republic of Moldova, and you can see, let's say, the whole county of Iași. As I mentioned before, Iași is not just a city, it's an experience. Yeah, and I will try, let's say, next year to invite Harshit to have a lecture on our master degree, yeah, on intelligent manufacturing, starting on this autumn, yeah, but we'll have more, let's say, action to do for that. Iași is located on northeast of Romania and built on 7 hills. There is also another city in Europe built on 7 hills, I mean Rome, yeah, the capital of Italy. Iași is one of the leading centers of Romania's social, cultural, academic, and artistic life, and has a humid continental type climate. Summertime it's dry climate, and the temperature grow up, let's say 35, even more than 35 degree. So discover Iași city a little bit. Yeah, some picture, National Theatre, Culture Palace, very nice culture, and this palace has 365 rooms, yeah, inside. Yeah, as I mentioned before. Yeah, look a little bit about the universities from our city. I mean Alexandru Ioan Cuza University of Iași, our University Gheorghe Saki, University of Medicine and Pharmacy, University of Life Sciences, and National University of Arts. So let's say altogether more than 60,000 students. You can see our aula, yeah, from Gheorghe Saki Technical University of Iași, and a little bit some information. I mean our university in figures. We have around 14,000 students, I mean on bachelor, master, and doctoral studies, 1,500 international students, and over 600 international agreements. Excellency in research, 24 research centers with accredited research labs. And let's say a little bit about the English taught programs, Master of Science, and you can see on different faculties, I mean on civil engineering, automation control, electronics, chemical engineering, and our faculty. We'll start with intelligent manufacturing and Automation is the English course. And of course, if you are interested, we can talk about this master degree. I don't know why it's working so. And postdoctoral programs, you can see over there on different faculties. You can, your students, of course, can attend, our, let's say, PhD programs, also in English. So a little bit more about the intelligent manufacturing and automation master in English, because I'm director of this master, and I think it's important to know about this master more. Study in intelligent manufacturing and automation, and of course for graduated having, let's say, knowledge of manufacturing technologies and wishing to depend their expertise in several professional direction. Learning outcomes, you can see on the left side, I mean, use the most advanced software for simulation and modeling of manufacturing processes, design method of manufacturing processes, knowledge of both advanced manufacturing technology for wide class of composite materials, but also for automation processes, and of course, assimilation, knowledge on sustainable development through innovation. You can see the structure. I put also the information about the structure of the master. I mean, what are the main courses, what are the main lectures on the first year. You can see manufacturing simulation, computer-aided experimental research, let's say advanced welding, non-traditional manufacturing processes, fluid power system, and elective courses, statistical data processing, also management risk. It's important from our point of view because, of course, only in Romania we have a master about the management and production. So it's important our students to make a connection between the engineering problems and the management system. Also, you can see on the second year, advanced manufacturing automation processes, advanced manufacturing technologies of composite material, intelligent manufacturing, advanced welding technology, because you know, welding technology, let's say it's a huge specialization, and the welding engineering are, you know, good opportunity to find many companies for working. And elective courses, enterprises, resource planning, sustainability development, through technological innovation. So the main idea about the structure of this course. And
no
please.
courses on single crystalline material development, like chemical vapor deposition or Czochralski kind of a process.
PVD process, and so on. Yeah, it's a part of advanced, let's say, technological processes.
But there are courses on that?
Yeah, there are included on this structure of the master. Yeah, we can do, of course. So the contact information, of course, but if you or maybe your students are interested, please contact me because I'm director of this master. So let's have a starting point. I mean, for making friends for life, it's important for our future, especially for the young researcher and your young colleagues, because let's say more or less me and Harshit, I think we overcome this barrier, isn't it, Harshit? And this is quite important. Let's see a little bit about our infrastructure. I mean, my lab and material science lab, because we have a connection with material science characterization lab, and we're working together. So we are on the part of manufacturing, they are on the part of characterization of material, and this is quite important. You can see a little bit a lab of precision mechanics and nanotechnology with the field of expertise. This is my lab. CNC manufacturing, computer-aided design and computer-aided manufacturing, additive manufacturing. I saw that the over there, National Institute of Technology, was made by 3D printing, on your lab here. Injection molding of composite material. And of course, it's important afterwards to study the material, because on the last years, as you see, let's say to make an idea, to share with you an idea about 25 years ago, yeah? When I started the university, let's say as assistant professor, yeah, I sent many papers focused only on manufacturing, yeah, on different national journal and so on. But on the last years, yeah, many journals asked for us to make the characterization of materials. Yeah? So it's not enough only to talk about the technologies, to talk about the step of technology. It's important nowadays to make the characterization of materials. So between the materials and manufacturing, I think, as my opinion, it's a good connection. So it's a compulsory connection. So we have to get more and more knowledge about the materials, yeah, and of course to make a connection with the technologies. So from this point of view, you can see the material science lab from mechanical engineering faculty, because we have a possibility to study of advanced materials, diagnostic and technical expertise, and you can see over there some equipments, metallographic, digital camera, microscope, electronic microscope, X-ray diffractometric, plant plasma jet deposition equipment, and of course the others equipments. So about this part, if you want to have some questions, to put some questions about my university, about my faculty, please do it.
You have a mechanical engineering department separately.
Yes, yes.
In that itself, you have all heat engines, combustion.
Yes, on mechanical engineering faculty. As I mentioned before, that's why I mentioned before, yeah, because now we are 3 different faculties: material science faculties, machine manufacturing and management, industrial management, the faculty where I'm working, and mechanical engineering. On mechanical engineering, there is, you know, the department that you already mentioned. But we are working together, yeah? We are working together. We share the equipments and so on. So we are working together over there. This is quite important. I think the important step for us, yeah, as I talk with Harshit, is to sign an Erasmus agreement, because it's a very good tools. I have an Erasmus agreement with Bangalore, yeah, here on India, yeah. But I think it's better to sign an Erasmus agreement with you, because the Erasmus agreement, it's the best tool to invite you in our university, to present your research, to have a lecture inside of our, let's say, bachelor students, PhD students, and so on, and to see and to know each other better. I think this is the good opportunity and the compulsory step to follow, yeah, why not, maybe this year. Okay, so let's now make, a short introduction about my lectures, yeah, for this week. I will have 8 lectures, yeah, 1 hour and a half each lecture, yeah, and hopefully my presentation will be useful for you. As my opinion, my lecture try to create a general idea, yeah, about not only my research, because it is not only my research. Okay, I have a team, a research team, yeah, that I'm working. Of course, I manage this team, but I have a team, and we can share the experience with you. I'm eager also to see your labs, yeah, during this week, and to establish, let's say, the common research. So I will start today with the introduction, focus on short history of composite materials. It's important. Well, thousands of years ago, we are talking about the composite material, but the people over time didn't know about the composite material. Evolution of engineering materials, afterwards advantage and disadvantage of composite materials, because we cannot talk only about the advantage. Always there are the disadvantage. Doesn't matter if we are talking about the composite, if we are talking about the technologies and so on. General classification of composite material. The second lecture, I mean the third lecture after Harshit, second one, processing of metal and ceramic composite. We'll try make here an idea about processing method for metals and ceramics in terms of 5 categories, and you'll see what means 5 categories. Metal matrix composite processes afterwards, industrial application of MMC, okay? Ceramic matrix composite processes, and industrial application of CMC. Of course, I will mention the industrial application, you know, as a general idea, yeah, because we have not enough time to develop, let's say, the real industrial application. I will develop a little bit because I found it extremely important, yeah, which are the main steps in order to make a design of the injection mold, yeah. I don't know if you are working here on injection molding. Are you working? Okay. And have you a project in injection molding?
Yeah,
how to design? Oh, this is quite good. We can share the experience. I choose, let's say, not a complex part, a simple part, yeah, that I'm using also in front of our students and in front of the Poland students also. But I think it's important to know the main steps. And of course, the industrial application of CMC. The next lecture will focus on biodegradable composite material. As you can see over there, the general classification of liquid wood and technology properties of liquid wood. So liquid wood is the biodegradable material. We'll see there are several types of liquid wood. Yeah? Let's say the patent belongs to Fraunhofer Institute on Germany, and the industrial production belongs to the Technaro company also in Germany. In 2016, on our Motec International Conference, we had one plenary speaker from Fraunhofer Institute of Technology from Germany. And this biodegradable material, it's quite interesting and, let's say, useful for many, many applications. Because, you know, nowadays the trend is to replace, as I mentioned before, to replace the plastic materials with the biodegradable materials. There are, as my opinion, small parts, small steps so far, yeah? Because we replace on the supermarket what? Bags, yeah, and so on, yeah, different small parts. But take into account the huge plastic industry, yeah? I don't know to say how many years we need in front, yeah, to replace, let's say, 30% of plastic materials. Well, it's very difficult. But maybe the next generation, maybe young researcher, we find the solution, yeah, to carry on and to replace plastic material, you know, quickly. The next lectures, 3D printing of biodegradable material. This lecture will focus on, let's say, our research team on the national research project, which was closed 1.5 years ago. Yeah, we study, as you can see over there, 10 or 11 biodegradable materials. I mean PLA, impact PLA, and high density PLA grill, because you know PLA is one of the most used biodegradable material for the 3D printing. Extruded BDP flex, extruded BDP pearl, and BDP green tech. Fiber wood, it's quite interesting material because fiber wood gave to the products a good surface quality compared with the other materials. So fiber wood is quite good from this point of view. Biofila linen, biofila silk, and this is part of liquid wood. Yeah, you can see ArboBlend Nature, ArboFill, ArboBlend, reinforced with extruded BDP pearl. I mean, it's our material. Because what means the material research? Material research focus on how to create the new material. This is important. Yeah. So we can use, as you can see, a couple of slides. Yeah. We need a reinforcement and we need a matrix. Yeah. And all the properties, yeah, that the new products are required are based on the reinforcement and the matrix. So this is the important step, and it's important to create. So we try to use the liquid wood material to use some reinforcement and to get, you know, new material with better, with improved, let's say, properties. The next lecture, coated bio-based polymers. Well, actually, this part, let's say, is our last research, yeah? And the second one, I mean, improvement arboblend material characteristics through coating with silver nanoparticle. It's actually, let's say, my last PhD student, yeah? Now, of course, she is a doctor. It's quite interesting idea to make the granules of coated, the granules of biodegradable material coated with silver nanoparticle using PVD process, okay? And afterwards to get different products using the injection molding technology, yeah? It's not coating on the surface, it's coating on the granules, okay? So it's important from this point of view. The first point on this lecture will be focused on improvements of arboblend nature characteristics through depositing thin ceramic layers. Okay? Also, it's important because this part is usually used on automotive industry. Yeah? Hardness surfaces, yeah, of course, on other industrial application, but we are focused, yeah, on automotive industry. The next one, laser surface texturing and water jet cutting of liquid wood. Yeah? I'm sure that you already know what means LST technology, laser surface texturing. Actually, this is the international, let's say, research activity, because it's my PhD student now working, but it's, you know, co-tutel with the technology, Silesian University of Technology, Gliwice, Poland, where I'm working also as visiting professor, started from 2017. Yeah, they have good equipments. I mean, good laser. Yeah, from this point of view, we got the part from the liquid wood, and afterwards, yeah, the part, let's say, improving the the surface characteristics using LST technology. We are doing on mechanical engineering faculty from Gliwice. And of course, water jet cutting of liquid wood is also another doctor of mine, yeah, PhD students, will see what means and what is the advantage of water jet cutting technology. The next lecture, technology for plastic material parts.
Water jet cutting machine, sir. It is only water jet cutting machine. Water jet cutting machine, not abrasive.
Water jet technology. Yeah, we can cut the material, even it is the metal or plastic, using water jet. Yeah, of course, under the pressure.
One more concept, abrasive water jet cutting.
We can use without abrasive, we can use with abrasive. Yeah, this is the main idea which we can find in the technical literature. Yeah, the technical literature mention that on the plastic material you can cut it without abrasive, but it's not true, really, because I started the research without abrasive material inside of the water jet, and was not possible. Yeah, was not possible. The thickness of our part was around 10 millimeters, okay, and was not possible to cut it without abrasive. So we put the abrasive, of course, all the connection, all the calculus, and so on, and was okay. Okay? Okay. So the next lecture, technology for plastic material parts. Yeah? Maybe you can ask me why you didn't start with this part. Because this part show us, yeah, which are the technology for the plastic material. Because in case of injection molding, yeah, of course we can use the same technology for biodegradable material. Yeah? It's about only the parameters and so on, melting temperature and so on, because as you already know, in case of biodegradable materials, the melting points of quartz, it's lower. Yeah, in case of our material, liquid wood material, it's around, let's say for our arboblend, 150, 170, compared with the other plastic material with more than 300 Celsius as melting temperature. We save a lot of energy, yeah, from this point of view. So we are talking here about the pressing process, transfer process, injection molding process, part and half finished products from plastic sheets, and also coating technology with plastic material.
So,
Please.
injection molding process, transfer process. Still,
Transfer process, it's more or less, let's say, injection molding. Let's say, but there are differences. Yeah, between transfer. It's about also the productivity, because you know the injection molding technology is with the highest production technology, but transfer one is not. Transfer one is, let's say, improved technology compared with the pressing process, because the pressing process do not allow us to obtain the complex part, because we have to see exactly the material state, okay? Because during the injection molding, the material is melted one, yeah? But on the pressing process, it's not melted one. This is the reason why, we cannot obtain the complex part. Please.
Injection molding processes. So I have doubt. Still, in the future, there is a scope will be there for injection molding process, because nowadays they are moving on 3D printing. People are moving to.
But yes, I understood what you said. Yeah, you know, nowadays we are talking about 3D printers, okay?
Yes.
But 3D printing technology we cannot compare with the injection molding technology because of the production. Yeah, maybe in the future, I don't know how, I don't know when. Yeah, we can increase the 3D printing productivity. I don't know how. Okay, as you already know, the Ford company, make some parts of from automotive industry using 3D printing. In US, the houses, they started to make houses using the 3D printing. In Canada, and now I think in Netherlands, during the restaurant we can eat, different type of meat, obtained by 3D printing and so on, but without productivity. So the injection molding has the highest productivity from this point of view. Yeah. So maybe who knows? Maybe you, will get an idea in the future. Yeah, how to increase the productivity for 3D printing. Yeah, I don't know. Okay. And the last lecture, composite material reinforced with particles. We will talk here about the technologies for composite materials reinforced with particle, the gas to liquid transfer of the reinforcing particle. Maybe it will be a little bit boring for you because it's it's a theory, but up to the let's say industrial application, each researcher, is my opinion, of course, is your opinion, must to know better and better the theory, because it's important how to apply the characteristic, how to apply the theory in order to obtain the good results for the final materials. Afterwards, experimental results of the gas liquid and liquid solid transfer of the reinforcing particles, properties of composite materials reinforced with silicon carbon particles. Yeah, actually, also it's I think 8 years ago, our own research, from this point of view. Okay, so I made a presentation, let's say outline, general presentation of my lectures during this week, and now, if is it allowed from your side, I will start with the introduction part. If you want to take notes, please let me know. Do you want?
Yes.
Because I have to share my presentation time with you. I mean, I have to wait you to make a little bit figures, to write some ideas and so on. I didn't know about this aspect, about the taking notes. I asked also Harshit, and he said, well, it's possible. Please ask at the very beginning. Okay. So the short, please.
Slides will be shared, or?
Yeah, I think so. Why not? I think so. Yeah? Yeah, always the students ask at the very beginning. Yeah. Professor, will you give us the lecture? If I say at the very beginning, yes, nobody wants to take notes. For sure. and but not in front of you now, because now we are not, let's say, usually classes or something like that. Okay, but at the very beginning, because I had a big experience, more than 30 years. Yeah, when the student asked me, yeah, I said no. I said no.
One of the issues in India
Yeah.
is a lot of agricultural byproduct, after agricultural, that is handling agricultural waste. Handling that has become a big issue.
Yeah, yeah.
So
yeah.
I think in your composites, if something can be done towards utilizing them in producing composite materials of use, you can throw some light on. Agricultural waste handling is a big issue in India.
Yeah.
Fibers, bamboos.
Yeah, but actually so far I didn't use, yeah, let's say the
That is
composite
really
from the agriculture
Plant fibers.
area.
but-
I have a connection, good connection with one professor from ES. I don't want to mention the name and the institution because of the recording today. Yeah, which are working, the teams over there which are working on composite material but using the reinforcement from agriculture area. Of course, it's very interesting. We can start, yeah, let's say a small research direction from this point of view with different, let's say, reinforcement part. I mean the origin of the reinforcement. We can do it. Okay,
Okay, Professor, I have to take
you have to leave.
Yeah.
Okay. So,
Sir, can you differentiate between composite material and alloy? What is the main difference between composite material and alloy?
when I'm talking about alloy, we are talking different one. Okay? We cannot talk about alloy, let's say, on composite. It's, as my opinion, we will talk about alloy and material, metal alloys and so on the metal part of composite. Okay? Okay, so short history of composite material. Yeah? As you already know. Yeah? As I mentioned before, there are, let's say, several times, yeah, when the composite material were used. You can see in 1200 before Christ. You can see over there, Mongols invented the first composite bow. Material used, which were wood, over there were sinew, leather, bamboo, and another one, worm and antler, naturally flexible and resilient. Okay? Glue from blender of fish, strings, sinew, horse hair, silk, and so on. So there are, as our opinion, several composite material used, yeah, thousand and thousand years ago. 1300 before also Christ, Egyptians and Mesopotamians used straw bricks. Okay, another one, 4000 before Christ. You can see over there laminated writing material from the papyrus plant. Yeah, all of example are, let's say, composite materials. But of course, the ancient people over the time didn't make, of course, the research. Only they use the composite material. As I mentioned before, it's important to start which are the main parts, let's say, of the composite. We are talking about the matrix as main component, and we are talking the reinforcement, of course, as main component. Yeah, doesn't matter the reinforcement will be, let's say, 5%, 10%, 25%, but it's important because without, we cannot talk about composite materials. As professor from my right side on the inaugural ceremony mentioned, without you, we cannot talk about the speaker. so without students, you cannot talk about professors. Okay? So the audience is also quite important, I mean in behavior of the lecture, of the courses, and so on. So the matrix sets up the part geometrically, gives cohesion to the material, usually flexible and not very resistant, and transmits what? Efforts from one fiber to another. The reinforcement provide rigidity and resistance. from another point here, reinforcing phase could be fibers, particle, flakes. Okay? Matrix phase, polymers, metals, ceramics. All together, put all together, I mean the matrix and the reinforcement, we can obtain the composite material. And what is composite material? You can find the definition, yeah, very, very easy, yeah, on internet and so on. The composite material consists of at least 2 or more materials, okay, which combine to give the higher or improved property, because from time to time we cannot obtain the higher properties. But what do you think? The research is important or not? The failed research is also it's important, because if your colleague, yeah, let's say didn't obtain the good results, the important results, yeah, all of you know that he didn't. So you will not carry on this direction. Yeah? This is the important, also the failed research results is also important. Okay, composites are by no means the right materials to every job. Also, it's important conclusion. When should you use the composite? This is also important goal, because the combination, as I mentioned before, between matrix and composite can be changed, take into account all the requirements. Okay? I met many years ago one professor from Taiwan. Yeah? Now he's on retired time. And he said to me, Dumitru, I'm the expert, yeah, in materials. Why, professor? Because you have to tell me what do you want to obtain, yeah, and I will make the material. So this is important, okay? So which are the requirements for the final product, yeah? And afterwards, after we define very well the final requirements, yeah, we can start it to choose the matrix, to choose the reinforcement, which is the percent of the reinforcement, and so on. So the combination of the reinforcement and the matrix can be changed to meet the required final properties of the component. I mean, let's say the main requirements, because over there are not all the requirements, of course. I mean, weight reduction. It's important, the weight reduction or not? It's important, yeah, especially on the aircraft, yeah, aerospace industry. Yeah, to make the weight reduction, it's very important. Durability and maintenance, added functionality. Okay, last but not least, the design freedom. So let's see some final requirements, yeah, in order to obtain the composite material. So if you want to take notes, please let me know. So my proposal is to look for you, yeah, and to make a break, okay? Of course, enhance desired properties. And I try here to make a general, let's say, idea, yeah, about 4 main questions. I mean, what are these desired properties? What are the constituents in composite? I will skip this one because I already mentioned it, okay? What are the function of the matrix, I mean, development, yeah, function of the matrix, and what are the function of the reinforcement? So, which are the desired properties? You can see over there, yeah, the main, let's say desired properties. Of course, there are many. Yeah, I put, let's say, the main important desired properties as strength, stiffness, okay, toughness, corrosion resistance, wear, resistance, reduced weight, as I mentioned before, fatigue life, thermal, electrical insulation, and conductivity. Okay, it's also important desired properties. Acoustic insulation, energy dissipation, attractiveness, and cost. Not last one, yeah, because also always, you know, The cost is the important, let's say, factor. And in order to reduce the cost, many companies try to make a balance between quality and cost, okay? Because it's up to the market, yeah? We are talking different on, let's say, on different countries. We are talking different on the developed countries and so on, yeah? So the most balance between quality and cost, it's important for many, many companies. Also, what are the functions of the reinforcement? I mentioned contribute desired property, load carrying, transfer the strength to the matrix, okay? I will skip what are the constituents of the composite material and what are the function of the matrix. Of course, holds the fiber together, first, okay? Second one, distributes the load evenly between fibers. Enhances some properties of the resulting material and structural components. I mean that fiber alone is not able to impart. So the fiber alone is nothing, okay? Without matrix, of course, suitable matrix from this point of view. Okay, and provides better finishing to the final products. It's also very important to have the better and better finish, let's say, for the final product. If not, what do we have to do? To change, to change, to study again, to make a research again, to make another matrix, to find another reinforcement elements, and so on. Because the quality of the surface, it's very important. Okay, if you want to write something from this slide, if not, the composite, are fixed by properties of the fiber, properties of the resin, the ratio between fiber, the ratio of the fiber to resin in composite. We can talk about the fiber volume fraction, okay? The geometry and orientation of the fiber is also important because gives us different properties, the orientation. It's important, the orientation of the fiber. And designing with the composite, please don't forget that designing with the composite, there are 4 main direct loads that any materials in a structure has to withstand. I mean, tensile, compression, shear, and flexure. Okay? It's important from this point of view. And you can see over there, which is the diagram between tensile stress and strain in case of fiber, I mean, alone in case of FRP, it's fiber reinforced plastic composite, and in case of resin, similar one, what means, which is the tensile strength in case of fiber, in case of composite, and in case only the matrix. What is shear, what is the flexure, Yes. So it's not important to highlight again, Maybe the flexure loads are really a combination of tensile, compression, and shear. Maybe it's important, okay, to know, because when loaded, as shown on the figure, the upper face is put into compression, okay, and the lower face into tension, as you can see over there. So there are, let's say, 4 generations of composites so far, I will, let's say, make a short information about the 4 generations of composite. You can see the first generation appears in 1940, okay? So the glass fiber reinforced composite, The yearliest application of glass fiber reinforced composite products were in marine industry, okay? Another important point of view, fiberglass boats were manufacturing in early 1940s, okay? to replace traditional wood or metal boats from many disadvantage from this point of view, okay? Concerning the metal and wood material used for boats. The Allied forces landing in Normandy in 1944 arrived in ships made using the glass fiber reinforced composite. And fiberglass nowadays continues to be a major component on boats and ships nowadays. The second generation started in 1960, okay? High performance composite in the post-Sputnik era. We are talking about the major world event was the launch of Soviet Sputnik satellite in 1955, okay? And space race that it prompted, because the heat generated during the re-entry of the spacecraft into Earth's atmosphere could exceed more than 1,500 Celsius, yeah? So we have a special composite material from this point of view. Another, you can see in 1965, let's say another important event during the second generation of composite material in Cincinnati development labs added asbest fiber to the phenolic resin for use as much as possible re-entry, let's say the aircraft into the atmosphere, yeah? So they developed, let's say, interesting material from this point of view. In 1971, DuPont introduced the world to Kevlar, you know, a fiber, yeah, based on aramid compounds developed by Volek in 1964.
Bulletproof. Carbon fiber reinforced plastics system.
We'll see next about the carbon fiber. Yeah?
That's
Second generation was about thermal loads.
Yeah.
so still it is going on.
So the thermal properties is very important, yeah, from the point of view for the composite.
The first two also still is going on, sir. Other stuff.
Yes, of course, yeah, yeah. Fourth generation, 1970, 1980. The search of new material and the synergy of the properties. Okay, let's say this was the main goal, yeah, of the fourth generation of composite material. Sports and automotive industry became the more important markets from this point of view. Carbon fibers, okay, were used extensively in sporting goods beginning of the 1970s, yeah, and so on and so on and so on. The fourth generation of composite, yeah, now we are going forward to the hybrid materials, nano-composite materials, because you know what we want to do on the world research, to make what? Small and small products, yeah, with hybrid one, with higher and higher properties, yeah, from this point of view. So concerning the hybrid material, nano-composite, in the 1990s, both academic and industrial, let's say, and institute research, yeah, started to extend the composite paradigm to the smaller and smaller scales. Okay, this is the main idea from this point of view. Toward to the nanoscale, we are talking about the nano-composite. Another important event, metal matrix composite, and we will call forward MMC composite, okay? And ceramic matrix composite, CMC composite, yeah? Frequently, let's say, mimic the design with small particle, let's say, of ceramic silicon carbon, used as reinforcement in aluminum, or small particle of zirconia in aluminum. And of course, the other, let's say, two important conclusion concerning the fourth generation of composite material. Yeah, what do you think? The second one started? The next generation of composite started or not? What do you think? Started, okay? Okay. So, a little bit more about during the fourth generation. which appeared metal matrix composite. And you can see over there, but I will skip this conclusion, okay, because you already know. And of course, during also the fourth generation appeared the ceramic matrix composite. You know, because of the higher properties focus on hardness of the surface, the ceramic matrix, the ceramic composite are very important, okay, in different industrial applications. Yeah. Evolution of the engineering materials. I think it's quite important figure, yeah, to make an idea, yeah, which is the evolution of the engineering. You can see, as I mentioned before, concerning the history of composite material, 10,000 before, okay, crisis, you can see. And the information, it's, let's say, quite new, okay, using the source over there, because the last year is 2020. So, not so, let's say, far away. Yeah, it's only 3 years between the information. And what you can see over there, that important, let's say, year, it's somewhere over here, okay? 90, let's say 50, yeah, when the research, deeply research on composite material started, yeah? Doesn't matter if we are talking about the ceramic, the metallic, the plastic, and so on, yeah? You can see over there which is the main, properties concerning the polymer's request properties. In case of polymer, composite, ceramics, yeah? You can see a high density of the material, okay, in this part, on the last, let's say, 70 years, okay? Will be faster, faster, I think, is my opinion. And now, advantage and disadvantage of composite material. Weight reduction, I mentioned before, because saving in this range about 20 up to 50%, yeah, concerning the weight of the final product. Mechanical properties, also it's important to be improved. High impact resistance, high damage tolerance, galvanic electrical corrosion problems, design flexibility, improve productivity. And of course we can carry on, yeah, with some, let's say, advantages of composite material. But in the same time, there are many disadvantages, and you can see over there some higher recurring costs, isn't it? You know, but it's a general conclusion about the products, yeah? When I'm looking at the mobile phone, yeah, you can see the new one started on the market with a higher price. Yet after 1 year, yeah, it decreases, suddenly decreases, yeah, and it's allowed for us to buy it, okay? So this is the same, let's say, doesn't matter the industry, doesn't matter the products, automotive and so on. Higher non-recurring cost, higher material cost, you can see on the next slide, because also, yeah, at the very beginning we have, let's say, higher material cost, non-visible impact damage, repairs are different than those to the metal structure, isolation, composite are brittle and thus are more easily damageable, okay? So also it's important. And now let's have a look a little bit about cost of material and of course cost of the production. Because if you want to see and to make an idea about the fabrication cost, you can see here the present concerning the tool preparation, collet price, back and cure, trim, innovation research, cut price, okay? I think also it's important innovation, research and development, okay? So on the last year, many companies developed inside, yeah, the department with own research, yeah? And the 50%, I think it's not, you know, a fixed one. Could be higher, could be lower, yeah, 50%. And it's important to have own research. You can say also, but the company can buy the research, yeah, from outsource, yeah, of course. Of course, if the balance between the price and the results are good, yeah, of course, they can buy it, yeah. Why? was necessary, why it is necessary, to make inside research department. Also, the total cost, you can see material and fabrication around 50%, and the fasteners and assembly about 50%. It's not fixed one, okay? It's up to the industry, it's up to the company, and so on. And if you are looking to the cost per kilo of the material, as I mentioned before, you can see 100% in case of ceramics, okay? In case of metal and alloys, another one, I mean higher one, composite with 65%, and you can see over there the polymer foams, okay? Also around 60%. Of course, also cost of production, because cost of the production are in connection, with the cost of material. And you can see also we can find over there ceramics, we can find metals and alloys, composite, and rubber, polymers, and polymers foams. There are also, of course, another example that you can put on the diagrams, but it's important to keep in your mind, which is, let's say, the main material, composite material, and the link with the production, per unit volume. Okay? The cost for?
If the volume is more, then
The cost will be low, yeah. General classification of composite material. So, based on type of a matrix composite, of course, you already know. We are talking about polymers, metal, ceramic, carbon, and graphite. In case of polymer, we can have the thermoset and thermoplastic, and it's important to have an idea, to make an idea about the purpose of the matrix, as I mentioned before, and to make a general idea what means CMC, PMC, and MMC composite material. I mean, which are the main properties increases, on each composite material. I think it's a good diagram to see in case of CMC material that the toughness is increases. Okay? So you can see in case the diagram between force and bend displacement, you can see the diagram only for the particle reinforcement, fiber reinforcement, and the material without reinforcement. Okay? So in case of PMC, please keep in your mind that the ratio between Young modulus and the density will increases. Okay? So you can see what means in case, which are the value in case of PMC, in case of polymer, this area, and in case of ceramics. And what happened in MMC? Increase creep resistance. And I put here some information you can see about the aluminum with silicon carbon whiskers and so on. To make only the general idea, of course, there are not only the property that increase in case of CMC, PMC, and MMC materials. And based on the type of the reinforcement, you can see the classification. Fiber, whiskers, flake, particulate, okay? In case of fiber, continuous fiber, discontinuous fiber, unidirectional, woven, continuous, discontinuous fibers concerning the orientation can be random and preferred orientation, okay? And of course, the diagram can continue. And in case of particulate one, we have also the random orientation and preferred orientation of the particles.
Is there a limit on the size of the particle? Like you can put macro, micro, nano?
We can use also powder. We can use also powder because powder is in nanoscale. Let's say on micro also scale. We can use different particles, different dimension also of the particle, with different shape of the particle. Also, it's important, you know, because in theoretical aspects, we'll take into account, let's say, circular shape of the particle. But on reality, it wasn't a real shape. We make only the approximation, yeah, in order to make the calculus and so on. Okay? Based on geometry and orientation of the reinforcement phase, you can see the composite particle reinforced, fiber reinforced, and structural one. In case of particle reinforced, avem large particle, dispersion. In case of fiber reinforcement, continuous, discontinuous. And in case of structural, laminates and sandwich panels. In case of discontinuous, of course, we can talk about the line and the randomly orientation. As I mentioned before, in case of PMC, composite material, we can talk about the thermoplastic, and I put over there some information about, you know, thermoplastic material, polypropylene, PVC, nylon, and so on, PA, kappa, PPC, and so on. Let's say other thermoplastics material used, yeah, in our let's say research. I mean, the thermoplastic material processing is faster than thermoset composite, okay, since no curing reaction is required. Thermoplastic composite required only heating, shaping, and cooling. Yeah, three main aspects. Also, better properties. I mean, we can obtain the high toughness and damage tolerance, low moisture absorption, chemical resistant, but they have low, and also they have low toxicity. Is very important from this point of view. The PMC also, the second category, I mean thermosets. I put also some material over there, such as polyesters, but epoxy resins, polyamides, and some properties, let's say, for each. I mean, in case of polyester, low cost, good mechanical strength, low viscosity, versatility, good electrical properties, and so on. In case of epoxy resin, are widely used for the most advanced composite. Why? Because the material has low screen cage during the curing, high strength and flexibility, yeah, and all the properties, of course, we can carry on with the better adhesion between fiber and matrix, better electrical property, resistance to the chemical and different solvents, and so on. And polyamides, excellent mechanical strength from this point of view, excellent strength retention for long term in range of 260 up to 315 Celsius. Yeah, it's important to have from this point of view a range of the temperature, good fire resistance, and low smoke emission. Hot molding under the pressure, curing temperature, it's around 175 Celsius. So, carbon.
Processing epoxy, we need some corners, right, sir? Like data. Corner is required to process the composite.
Yeah. So concerning the MMC, you can see over there aluminium, titanium, copper. For example, higher use temperature range. In case of aluminum matrix composite, use temperature range above 300 Celsius, and titanium around 800 Celsius. Higher transfer strength toughness also. The absence of the moisture and high thermal conductivity in case of copper. And of course also there are disadvantage, I mean heavier, more susceptible to interface degradation. In case of CMC, carbon, silicon carbon and silicon nitride, ceramic have used very high temperature range, yeah, could be higher than 2000 Celsius, high elastic modulus, low density, but also there are some disadvantage, brittleness, and of course the susceptibility to flow. And in case of carbon graphite, we can use the carbon fiber in the carbon matrix in, under the extreme mechanical and thermal loads, especially on space, okay, application, and some advantage over there, low specific weight, high heat absorption capacity, resistance to thermal, high resistance to damage, and so on. But also we can talk about the disadvantage, low resistance to oxidation, and of course, as I mentioned before, high cost of the material.
So why this material have high cost? Because carbon is very cheap, carbon and graphite.
But together with the matrix, up to the matrix used, yeah, the cost can be increased. It's up to the final product also. Yeah, no, now the carbon fiber, yeah, is cheap one. Yeah, but take into account the final product can be. It's not a general rule, I mean the high cost. Yeah, we are talking about the high cost of the final product and manufacturing. Yeah, look over there, material and manufacturing process. Because it's difficult, yeah, to have a technology in order to manufacture okay, the composite with carbon fiber. Yeah, it's difficult.
And so what is the meaning of susceptible to flow for the CMC?
Susceptibility to flow, what means?
Yeah, what does it mean?
Yeah, what do you think, what means flow in case of CMC?
Means that can be converted into liquid state, then we'll apply or
Yeah, could be. It's up to the application, yeah, could be, yeah, the possibility to flow the material. But also it's not a general rule, okay? It's up to the application. Because it's sustainability, okay? It's not, let's say, general rule, yeah, will be flow for sure, okay?
Any application of steel composites?
CMC is ceramic over there.
In
CMC.
MMC.
MMC, yeah.
It's there.
Metal matrix composite. Yeah. Yeah, steel, another metallic. Use different metallic.
And graphite,
Yeah,
almost same, carbon and graphite.
are almost, but not the same.
Not same, but some little.
Yeah.
Both are almost.
All of these categories, are they injection moldable, or some of them are and some of them are?
We will see afterwards. We will see afterwards the 5 categories, okay, of composite material, and we will give some example of the technology used. Okay, okay. Not all here are suitable for injection molding. No, no. Okay. Oh, we are at the end on the introduction 10 minutes earlier because Ragaval scared me and he said, Professor, short time for taking notes. Yeah. And I finished 10 minutes earlier. Okay. I would like to thank you for the first part, I mean introduction part. Maybe we have now time to take a tea, to take a coffee, up to the next presentation of Harshit.
Lunch.
Yeah? Oh, lunch, excuse me, lunch. Excuse me. I'm looking to my watch. That's why it's not lunch time. That I used was interesting for you. Yeah? We'll see the next one.
SR said we need
To share the PPT. Yeah, I will talk with Harshit, yeah, all together, okay, to make only maybe one PDF file, okay, all together with his presentation.
Just the end of the day, sir.
Yes, yeah, yeah,
So we'll go through.
but on the end of this week, not now. Okay, thank you.
Any student exchange
In?
any student exchange program in your university for doctorate students or for postgraduate students?
Yes, yes. Yes, of course. In our university about the doctoral study. Yeah, you ask me.
Student
Exchange.
exchange.
Erasmus.
6 months, 3
Yeah,
months exchange.
we are talking at the very beginning that's important to sign an Erasmus program because Erasmus program focus only student exchange and teacher exchange. Okay, we will sign. Yeah,
once
I
it
think
is-
up to the September, October we will sign. Yeah, and it's important Erasmus because you can spend in our universities 3 months up to 6 months, I think. Yeah, or something like that. To prepare, you know, the final project and so on. Yes, yes, yes. Yeah, it's important. I think we have a lot of
Without
Erasmus
MOU
contract.
Without MOU, it is
Only we sign now only the
With
memorandum
IAC
of understanding
With
that we will
IAC.
sign today. We sign today. I've been reading this week
okay.
with your institute, and afterwards this is the
Starting
first
point.
compulsory step. Yeah, you know, the general agreement between our university and your institute, and afterwards, for sure, yeah, together with Harshit, we will sign the Erasmus. Yeah, because
In India with IAC you have IAC Bangalore.
IAC,
Bangalore.
yes, in India, with Professor. Just a moment.